Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE online classes of relations and functions. Now we are beginning the concept of binary operations. Let us understand in the very outset what is a binary operation. A binary operation star, that's the notation, on a non-empty set A is a function star from A cross A, Cartesian product, alright, to A. So all the elements must be taken from the set A, alright. So how does an element in A cross A looks like? Ordered pair. So you are applying the function star to the ordered pair A comma B, and what is the output that you are getting? A star B, and that is a single element, a single answer, and that output must belong to A. Then we say star is a binary operation. So if the output does not belong, then that is not a function, because there are some elements which are not related to any elements of A, right? So then it does not become a function, hence it will not be a binary operation. So basically binary operation is a function. And what kind of a function? It is a function from the cross product of A to the set A. Well, now you have some properties, laws, which satisfied by the binary operation star. And if you are taking the set A and the binary operation star, then what is a commutative law? A star B must be equal to B star A. Alright, so for example, A plus B is equal to B plus A, whereas if you write A minus B, that is not equal to B minus A, right? So then it won't be commutative. A into B is equal to B into A. A divided by B is not equal to B divided by A, correct? Okay, so that is the basic thing here. Next, associative law, A star B star C is equal to A star B and then star C. So both must be equal, then it is called associative property, associative law. And all these ABCs are selected from the non-empty set A. Next, what is an identity element? See, identity element is E if it satisfies this rule. What is the rule? E star A must be equal to A star E. So first of all, it must be commutative, and then that must be equal to A. So for example, 5 plus 0 is equal to 0 plus 5 is equal to 5. So 0 is the identity element for addition in integers, you can say in integers, right? So next, what is the inverse law? Inverse law. Understand, you must have an identity for the particular binary operation. If you don't have the identity element, you cannot define inverse. Okay, so let us take an identity element E from the set A for the particular binary operation star, and if A star B is equal to B star A and that is equal to the identity element, then B, which also belongs to the same set, is the inverse of A in star and defined on the set A. Okay, so inverse element of A for star on A, for the binary operation star on A. To give an example, see if you have element 5 and you are talking about the addition, and that must be equal to the identity. What is the identity for addition? 0. Then what is the inverse of A, inverse of 5? So that will be minus 5. So minus 5 is inverse of 5. So for every A you get a different inverse. So every element has a unique inverse, but the identity element is same for that particular binary operation, whereas inverse changes, because if you take 6 here, then inverse is not -5, it will be -6, right? Identity element is same, 0 for addition. So every element has a unique one and only one inverse. Well, so that is about the introduction of binary operations, and that's all you have here. Now let us move to the examples, and now we are solving the examples of binary operations. First example, on the set of all natural numbers n, which one of the following star is a binary operation? What is a binary operation? It is a function from a cross a to a. That means if you take two elements, from the natural numbers, you have to take two elements from the natural numbers, and when you use the operation, what you get is a star b, and that element must also belong to the natural numbers. So this output must be in n, then only it will be a function. Otherwise, imagine you have two elements a and b. For example, I'll take 2 and 3. Okay, so what is star of 2 comma 3? 2 star 3. If you are going for the first option, then a star b is square root of ab. So what is 2 star 3? Square root of 2 into 3, which is root 6. Okay, so root 6 is what you are getting. So 2 comma 3, this will consist of elements in the ordered pair. There is only one element. Okay, so 2 comma 3 will go to root 6, but root 6 is not found in n. Okay, root 6 is not a natural number, that is irrational, correct? Okay, so that does not belong to the natural numbers. You don't have any element here. That means you don't have this arrow. That means this element does not have an image. That means star is not a function. Every element in the first set must be related to some element of the second set. Otherwise, that is not a function. Therefore, what we understand is star is not a function if you are taking a star b is equal to square root of ab. Therefore, this is not a binary relation. So which one of the following is a binary operation? So let's continue. What about the next thing? If you are going for the second option, then let's take the example of 2 star 3 itself. Then that will be 2 minus 3 divided by 2 plus 3, which is minus 1 by 5. So that also does not belong to natural numbers. So minus 1 by 5 is also not there. If you are going for the second option, that is also not a binary operation. What about the next? A star b is equal to a plus 3b. So if you are going for a plus 3b, then 2 plus 3 into 3. So 9 plus 2, 11, it belongs. So this, you can take any other example if you have doubt, and only positives, because it is natural numbers. You can't take negatives and 0. Okay, so take only positives. Hence this is also not a binary, this is a binary operation, I'm sorry. This is a binary operation. What about the last? So option D, if you are taking the same example, so that is 3 into a is 2, minus 4 into b. So in place of b you have 3, so 3, and that is equal to 6 minus 12, which is minus 6. That does not belong to natural numbers, does not belong because it is negative. You don't have that in the natural numbers. Therefore, this is also not a binary operation. So which is the right choice? Option C, and that's the only binary operation that you have. Well, so that is about whether given star is binary or not. Now let's move on to the next question. What does the second problem say? It says that if A star B is equal to maximum of A or B and A star dash B is equal to A star B, that means this value plus 3, then what is 4 star dash 7? So there are two different operations, one is star, another is star dash. Okay, don't be confused. Now let us start with this. What is 4 star 7? I'll go to star dash later. So I'm starting with 4 star 7 because when you apply you need this, right? Okay, so maximum among 4 and 7. So what is maximum among 4 and 7? Maximum is 7. So 4 star 7 is 7. Now you go for star dash. What does that say? It says that A star B plus 3. That means 4 star 7 plus 3. This is not star, that is plus. And what is 4 star 7? It is 7 and plus 3 will give you 10, and that's it. So option C is the right answer. So that is second question. Let's go to the third one now. Let star be a binary operation. It is given that it is binary, no doubt, defined by A star B is equal to 3AB by 5. Then star is it commutative, associative, both, or none of these? Let's go for it. All right, A star B. So A star B is equal to 3AB by 5. What is B star A? Understand, in place of A now you have got B. So when you write the answer in place of A, I must write B, and in place of B here I must write A divided by 5 is same. Now BA and AB, are they same? Yes. So B star A is equal to A star B, is it not? So if this happens, it is commutative. So star is commutative. Let's understand whether it is associative or not. Okay, so that is commutative. So what's next? Associative. Let's check that. When do you say a function is associative? If A star B star C is equal to A star B star C. So let's start with the first one. What is it? A star B, that is 3AB by 5, and then star C. Now once again you must use A star B formula. In place of A I have got 3AB by 5, so I must write in place of A 3AB by 5, and B is C. So in place of B I will write C. Understand? This is equal to 3AB by 5 and then C divided by 5. Understand? A star B, 3AB by 5. In place of A I have got this, and in place of B I have got this. That's it. Simplify. So that is like 9AB, and then C is also multiplied, divided by 5, and this is 5 by 1. When it goes up, it will be inverted, reciprocal, so that is 1 by 5. So that means it is 9ABC by 25. Correct? So what did I get? I got 9ABC by 25. Now let's go for the right hand side. So that is A star and then B star C. So A star I'll keep as it is. I'll use the formula A star B for B star C. Okay, so I'll use this formula. So what is B star C? 3BC by 5, correct? So this is 3BC by 5. Now A star B, that is 3A and then B by 5. Understand? A star B, 3AB by 5. In place of B I have got this. So in place of B I should write that quantity. So simplify again. So 3 into 3, 9 ABC by 5, and this 5 by 1 goes up. Okay, simple thing to understand. So 9 ABC by 25. So are they same? Yes. So they are equal, hence it is associative. So is it only commutative? No. Option A is not correct. Is it only associative? No. Is it only commutative? No. Is it only associative? No. But it is both A and B. So option C is the right choice. So if you say it is only commutative, it is also associative, right? So you must go for the option C. Well, so that is about the third question. Let's quickly go to the fourth question. Well, dear students, welcome back. So let's go to the fourth question of binary operation. Consider the statements A and B. There are two statements. What is the first statement? Star defined by A star B is equal to A plus B by 2 is binary on Z. Okay, and the same operation binary on Q. That's the only difference. First statement is that it is the operation star is binary on Z. Second statement, operation star is binary on Q. Which of the following is true? A only, B only, both A and B, none of them. All right, so that's the thing we have to analyze here. So let's begin. First, you have A star B, and that is A plus B by 2. So understand, I will take 2 star 3. Can I take? Yeah, so I can take 2 comma 3 from the set of integers. Then 2 star 3 is 2 plus 3 divided by 2, that is 5 by 2. Does it belong to the set of integers? So the outcome, the output, the resultant value must also be in the same set. Then only it will be binary operation. Otherwise it is not a function. Hence it is not a binary operation. As simple as that. Now 5 by 2, does it belong to the set of integers? No, it is a rational number. It does not belong to the set of integers. Hence this is not a binary operation. What about the next? You have to take two rational numbers. You take 1 by 2 and 1 by 3. Okay, and 1 by 2 plus 1 by 3 divided by 2 will be, let's analyze. I'll take 1 by 2 comma 1 by 3 on Q, talking about the second statement. And then what is half star 1 by 3? So that is half plus 1 by 3 divided by 2. So take the LCM 6, that will be 3 plus 2 by 6, 5 by 6 and divided by 2. This is 2 by 1. When it goes up 1 by 2, correct? So that will be 5 by 12, and it belongs to Q. It belongs to Q. So you have taken two elements from Q and the resultant is also in Q. Hence this is a binary operation, whereas this is not. So which option is correct? B only is true. So only B is true, A is not true. Well, so let's talk about the fifth question now. The fifth question, you have to identify the identity element for star given by A star B is equal to AB by 5. So 3, 5, 1 and 6. That's the thing you have. Now, what is the formula to find identity element? A star E should be equal to E star A, and that must be equal to the same element that we take here. Then this is called the identity element. So what's enough for us is this. All right, the first and the last, or you can take these two also. So all the three are equal. Okay, just two things are enough for us. Now what is A star B? AB by 5. So hence what is A star E? AE by 5, and that's equal to A, right? So you can cancel out A on both sides. So E by 5 is equal to 1, E is equal to 5, hence identity element is 5, and that's the option B, and that's the right answer. The sixth question is also finding the identity element, but the set is all the rational numbers except 1, and the operation is A star B. Alright, so there is no 1 in the set. So now what is the identity element? So A star B is equal to A plus B minus AB. Now what is A star E is equal to A? So A star B is A plus E minus AE, and that must be equal to A. So I am just using A star E formula, okay, A star B formula here. I hope that's understood. Okay, this is the rule to find the identity element. Okay, now see, this will be E minus AE, A minus A, which is 0. So A and minus A, correct. Now you can take E common, that is 1 minus A, that is 0. Now what we need is E, therefore this will be divided. 0 by 1 minus A is 0. So what is the identity element? 0 is the identity element. And does it belong to this set? Does it belong? Yes, it belongs to Q minus 1, because 0 is a rational number and only 1 is subtracted from that set, so 0 belongs. Well, therefore option A is the right answer. That's it for binary operations, and we complete the chapter relations and functions. Well, so thank you for watching.
Don't forget to like our video and subscribe our YouTube channel for all the updates.